All right. Well, I'm excited for everyone to take some time out of your busy schedules to join me today. And thank you for the introduction. I appreciate that. So my name's Dan Wahlin, as mentioned, and our goal today over the next about 45 minutes or so is to talk about how to get started with Docker containers. Now, I've been working with Docker for many years now. Actually, it's over, what are we at? 6 years old now, I believe, and worked with it quite a bit. And so we're going to be talking about kind of the fundamentals of what are the baby steps, if you will, to get into this. And maybe the more important question to ask is, why would you want to get into it? I know I asked that. Now, I come from a developer background, but at the same time, these days, I think a lot of us are doing not only developer things, but also some DevOps. So whether you're on either side of that fence, the developer side or the DevOps side, hopefully there is no fence at your work and you just talk, but this can apply to both groups in very impactful ways, we could say. So let's jump on in here right away with the agenda. And at the end of this, I'm going to have a link for you that I'll give to you. But we're going to start off this morning with the need for containers. From there, we're going to go into, so how can Docker help when it comes to these things that containers can help solve? What are some of the benefits to not only developers, but also DevOps and other scenarios? And then we'll start getting into these things called images and containers and talk about what those are and why you would actually care about those. We're going to wrap up with something that's extremely exciting, especially if you are on the development side, and that is something called Docker-Compose. Very powerful tool that's provided as part of Docker that we're going to get into. So let's start things off with a discussion of why do we need these things called containers? I know probably everybody here today has either worked with Docker or at least heard of Docker. It's been really popular, one of those big buzzwords over the last few years, of course. But when I first got started with it, like any technology, before I jump into it, one of the first things I do is kind of analyze what's in it for me. I don't know if that sounds selfish, but we all do this, I think. Why would I use this? How can it help my company? How can it help other companies I work with? Those types of questions. So some of you might have a scenario like this. You might have some type of a front-end application. Let's just say maybe you're doing some JavaScript in an app. Could be Angular, React, Vue, just pure JavaScript, whatever it is, and you're hosting that on a server. And in this case, we're going to say that server is Nginx, a very popular reverse proxy server that can serve up static content. But let's say that your application calls into a bunch of other APIs, and it could be ASP.NET Core, it could be Java, it could be Python, Node.js, whatever that may be. And then those APIs are then calling into one or more databases. We're also integrating with maybe a caching server like Redis. And you can see that we now have a lot of moving parts here. And if I was to come to you and say, all right, go ahead over the next couple hours here today, go ahead and get all this stuff installed. And I need you to make it run on your laptop too, by the way. But you only have till, say, lunch to get this done. Well, I think a lot of you that have been in the business very long are going to go, okay, well, I'm probably going to need more time because who knows what the API server requirements are? What type of security do we have? Are there things like environment variables? I have to set up the database. That might take a little bit to get right. And the list goes on and on and on. It's not just as simple as just run code. We need the actual servers, we need the security, we need the configuration, all those types of things need to be factored in here. So how easy is it to make all of these services run? And then let me add to that question by saying, how easy is it to make them run across development, staging, QA, production, whatever you call your different environments? And I think for a lot of you, that's probably a little bit more challenging. At least I know it was for me to get this up and running. In fact, to get something like that going in the past, just on my laptop, for example, was next to impossible back in the day. It just was either too much processing power or just too much time to get right. So with Docker, we actually have a way that we can run this different type of scenario, like Nginx, APIs, Redis, databases, anywhere we want. It could be local, it could be up in the cloud, it could be in your data center. It doesn't really matter. You can run this anywhere. Now, why is this important? Well, because if I could say, hey, I'm not only going to get you the code to run this, but I'm going to get you the entire environment to run this. And within a matter of minutes, you can get this up and running on your server. And I have some projects I'll be showing you along the way that will demonstrate this concept as we talk about it a little bit more. All right, so how can Docker help? Well, Docker provides the containers, and this is kind of one of their older logos that I really like. And you can see these shippy containers on the whale. And if you think about the old days of, think like 1700s, when ships actually came across the ocean, you know, you kind of have seen movies like Pirates of the Caribbean or things like that, where they have all kinds of different boxes and barrels and everything's a different shape. Now, you can imagine unloading those ships was probably a little bit challenging because there was no consistency at all. And so shipping and then unloading was, I suspect, a challenge. I didn't have to do it, obviously, but I'm going to take a wild guess. Now, today we know that ships actually have these shippy containers like you see here on the whales. And then because they're all standardized, it's pretty easy to get these containers on and off. I was in Spain a couple of years ago, and the port I was at, they were actually unloading a bunch of these containers, and I was amazed how fast they could actually unload this huge ship that just had all kinds of stuff. Well, that relates to us as either developers or DevOps, and you'll see that as we move along here. So how does Docker help? Well, it provides a shipping container system for code. Now, the first time I heard that, I can think of like 10 other things that you could probably say provide a shipping container system for code, but you'll see a little more about what I mean as we move along. Now, this runs natively on Linux, okay, or Windows Server 2016 or higher. You can run containers directly on either of these. It actually came out of the Linux world though, and we'll talk about that in just a moment as well. Now, when it comes to developers though, because you may not be in charge of the actual Linux servers or Windows servers you may have in production, from a developer standpoint, what's great about Docker is I can actually run these containers on my Windows machine, on Mac, or of course on Linux you can because it runs natively on Linux. And I'm going to show you that with something called Docker Desktop as we get started here. Now, the way this works is in order to run something like Nginx, an API, Redis, even a database could be containerized, we could say. We have to have something called a Docker image. Now, a Docker image, you'll see in a moment, is really just a layered file system. All right, so I think of it as like a chocolate cake with different layers to the cake. And then you have some frosting on top, which is what we call a readable, writable layer. Okay, but before we get into that too much, let's say that we wanted to run, for instance, ASP.NET Core on Ubuntu, and then we also want our code available as well. Well, if I told you that, that's my requirements. You have to have Ubuntu, you have to have ASP.NET Core, let's say 3.0, since it just came out, and then you have to run this code I'm going to give you. Well, then you would probably say, all right, well, I'm going to have to go set up a VM. I'm going to have to copy the code in. I'm going to have to install ASP.NET Core 3.0 on that particular VM image. And we'd have to do it that way. That's kind of the old way to do it. With an Docker image, and this is not a virtual machine, you'll see this comparison in just a moment here. This provides a template, if you will, that I can give you. And now with just one simple command, you can convert this into a running Docker container. And this would be now running ASP.NET Core on Ubuntu with the code that I gave you. And that you can do literally in a matter of seconds. And I'll demonstrate that coming up here in just a little bit. So think of an image as really just a read-only template. It's almost like a recipe for here's everything I need to cook up this pie. Or in our example, here's everything I need to run this part of the application. Now, as I showed earlier, you could have a web front end, you could have APIs, you could have databases and caching servers and on and on and on. Each one of those could have its own image. I can now publish that image or push that image up to a registry, which I'm going to show you as well coming up. And then you could simply pull that down and then convert it into a running container. And the day that I really got into this, I have what I call the light bulb moment, where I saw what an image was, I saw what a container was, but I didn't really, I hadn't used it yet, and it didn't really click. And the day that clicked and I had the light bulb moment was like one of those like, oh my gosh, this is phenomenal. Look what you can do with this. Everything my company does, our company website, our applications, and then I'm not going to say every company we work with, but many, they are now using these images as a read-only template, a recipe to create these containers. Now the container you can think of as the actual object. So if you come from a developer background, think of the image more like defining the code, but then to run the code, you have to run that somehow. You new up the object or create the whatever it is. That's kind of like the container. It's like your object that's now running. And now we could have Ubuntu with ASP.NET Core or Node.js or whatever it is you want, or you could even run Windows if you wanted on Windows Server 2016 or higher. Now, containers can then be started, they can be stopped, they can be paused, they can crash, of course, and then we could restart them and things like that. So here's how it works. An image, I mentioned earlier, is kind of like a chocolate cake. It's a layered file system. And so in the cake, we can have these different layers. Now, these are instructions. Don't let these are hash codes you see there, kind of nasty looking alphanumeric text. Well, that's an instruction like copy this code into the image or run this command or set this environment variable. Okay, that's what all those different layers will be. And I'm going to show you that as well coming up when we talk about Docker files. Now, this is a read-only type layer. It's kind of like opening a recipe cookbook if you like to cook. And you see that I have to, take 2 scoops of flour, and then I need a pinch of salt, and I need this and this. Well, that's exactly what this is. It's just a recipe, but this is the physical kind of ingredients, if you will, ready to go. So it would almost be like opening the recipe book and somehow magically through virtual reality, flour and sugar and salt magically shows up on your countertop. And now you can use that to actually bake whatever it is you're creating, the pie or whatever. Now, in our case, we're going to take this template and we're going to use it to create this container. Now, the container really is just the image, kind of like the cake, but the container part of it, I think of it as the frosting on top of the cake. So think of, again, like a wedding cake or any layered cake that you can imagine, and then put that frosting on top or whatever you may call that. And that's exactly what we have going on with this scenario right here. So we will create these images, or we will use someone else's image, and then that will be used to create a running container. Now, where's Docker run then? Well, as mentioned, the Docker client, which we're going to be using for the demos coming up, it came out of the Linux world. They have something called LXC, or Linux Container Support. And so it kind of runs natively there. There's a Docker daemon you can install on Linux, for example. Now, on Windows, they also have native container support now, and they have for several years at this point. Now, you might wonder about Mac. Well, Mac doesn't have native container support as of today. However, you can totally do it through virtualization. So I'll talk about that in just a second, and it has something called HyperKit that we can use behind the scenes. Now, one of the big questions before we start getting into the images and containers and running these that typically comes up is, so are Docker images or containers the same as virtual machines? And the answer is a very definite no. They are not virtual machines at all. Really, let me go back to this real quick here. Think of this base image, these layers that are kind of bluish here, as being layers that are being added onto an existing virtual machine. So let's imagine at the base of the cake is Ubuntu or Windows Server or whatever it may be that you want to use. And you're going to simply add additional layers on top of that base cake, kind of like a wedding cake where you have the really big base and then smaller ones as you move on up. That's exactly what we're doing. So that means that when I give you an image, it has everything it needs to run, but it's just the bare necessities to run. So instead of this multi-gigabyte virtual machine image that you might be used to, that when you fire up the guest OS, it now fires up its own memory, its own hard drive space. You get a copy pretty much of everything. So if we had a hypervisor such as Hyper-V or something else, then we could run Ubuntu as a guest OS, but it's going to have its own set of memory, hard drive, networking, everything. It's all copied, of course. Likewise, if you run a second guest OS on a different VM, then of course that eats up even more memory. Well, the difference with containers is that we're going to have our host operating system that Docker runs on, and we're simply going to drop these layers on top of that host operating system. So we don't have to make a brand new copy of the whole operating system. So when it comes to efficiency, these are very efficient. They're much smaller. And in fact, in some cases like Nginx that I mentioned, which we're going to look at in just a moment here, it's last I looked, it's between 16 to 18 megabytes total. Like that's the whole image, 16 to 18 megabytes. Crazy. Whereas if you were to grab the VM for that, of course, I'd have to look it up, but it's going to be a lot bigger than 16 to 18 megabytes. All right, now how do we work with this then? How do we, if we're on Windows or Mac or Linux, what do we do? Well, if you're on Linux, there's an install just for Linux you can get just to run these containers, but I'm going to focus more on Mac or Windows in this case. So if you're on Mac, you can run Docker Desktop, and I have a link down here at the bottom that if you go to that, you can get Docker Desktop installed in just a few minutes. It's very quick. And under the covers, this uses something called HyperKit for virtualization. So because containers don't run natively on Mac, at least at this point, hopefully that'll change sometime down the road, they have to create a virtualization for this. And so they do run a VM that's Alpine Linux. It's just a really lightweight virtual machine that runs these containers. It feels natural to you though. Like you don't really even know this, but under the covers, it's running this virtualization. Now, likewise on Windows, you kind of have a choice on Windows. It uses Hyper-V. So if you're running a Linux container on Windows, then Hyper-V will actually run the Linux. But you can also switch to run native Windows containers. And a Windows container might run something like IIS. You can even run ASP.NET Web Forms, for example, in a container, which these days is kind of a big deal as people are trying to move to more modern technologies and kind of get off of these older VMs or servers where the apps are located. This is one way we could do that. Now, both of these, if you're running Linux containers, use Alpine Linux under the covers, and then it just uses virtualization on Mac or on Windows to talk to this Alpine Linux VM. Now, as I mentioned, you can run Docker directly on Linux. You do have to install it, but it's a very straightforward process because it's kind of native to Linux anyway. And so they have documentation on that, but I'm going to focus on this Docker Desktop. So let's jump into a little demo here to get started. So you'll notice right up top, now this is my Mac, and you'll notice that I have this little Docker whale icon right up here at the top, and I can go to things like preferences. And in the preferences, I can get information about, like, do I want it to start when I log in, automatically check for updates. I can set up how many CPUs do I want my underlying VM to use, how much memory, swap disk, all that fun stuff. You can even link the VM to your local hard drive through something called volumes. That can be set up here in this file sharing. And then we can go on and on and on. In fact, you can even run Kubernetes if you wanted, which is a whole nother webinar, whole nother topic. Now on my Windows side, if we run over to Windows here, you're going to notice in my tray, I have Docker. And if I right click, I can go to settings. Very, very similar here. Okay, I can get to when do I want it to start up. these things called volumes or shared drives, Kubernetes, and on and on and on, all this fun stuff. Now, in order to get the whale icon here on either Windows or Mac, you will have to go to the link that I mentioned just a little bit earlier. So if we go back real quick to here, you're going to see this link right here. I won't go there now, but very simple. Just download it and get it installed. Very straightforward. Now, once you have it installed, what can you do? Well, the first thing you can do to kind of test it out, let me make this just a little bigger here, is we can just run the Docker command. This will kind of let you know, is your Docker daemon up and running, your engine, is it up and running? So I'm just going to say Docker enter, and notice it outputs all these different commands. All right, now don't let that intimidate you if you're new to this. Honestly, there's a handful of these commands that on a daily basis you need to know, but a lot of these I just don't use that much. But there are definitely some commands you'll want to know. For example, we talked about we have these things called images, which are kind of like recipes to create these containers. Well, I can run a command called docker images, and that will list all the images on my machine. And you'll see I have quite a few on here. Some of these are related to something called Kubernetes, but you'll notice up top I have Code with Dan, Nginx, Redis, Mongo. This is going to relate back to the screenshot I showed you earlier with Nginx and APIs and things. I have a Node image, a Mongo image, an Nginx, and on and on and on. Here's an ASP.NET Core image I also have here. Now, we can also list running containers. So Docker images list the images. If you want to list containers, you can say Docker PS. Think of this as a list the running processes. Now, I don't currently have any running, you'll notice. Okay, and I can also list any stopped containers, because containers could run and then you could pause or stop them by doing this. You can add a -A for list all of them, regardless if they're running or not running. And if I do that, of course, I don't have anything either at this point. Now, those are the basic commands to get us started, but how did I get these images on my machine in the first place? Well, that gets us to something called Docker Hub. So Nginx, as an example, let me go back to the top here. If you go to hub.docker.com, you can search, and I just went in and searched for Nginx, this reverse proxy. You'll see it's a very popular image. And then you can click on it here. And this will give you information about the version of the recipe, or in the proper terminology, the image. And you're going to notice right up here to the top, they have this Docker pull command. This is how you can pull an image either from Docker Hub or maybe from internal in your company, or maybe you're using Azure Container Registry or the AWS one or Google Cloud or whatever it may be. You can pull these images from different network resources. Now, in my case, if I want to come on back to, let me go to my Windows side on this one. And let's say I wanted Nginx, I could say Docker pull Nginx. Now, I'm going to grab a more lightweight version of Nginx. I'm going to add what's called a tag called Alpine. Now, there's different versions. If we go back real quick here, you're going to notice if I come on down to Alpine, it looks like 1.17.4-Alpine is the latest. Now, normally when you pull images, you want to be very specific about the version, because otherwise you'll grab the latest. In this case, I'm going to go ahead though and just grab the latest version, but it would be 1.17.4 it looks like. So I'm going to go ahead and run that. Now I've already run that on this machine, so it should be pretty quick, but this is going to go out and then pull. In fact, it must have changed since I ran it yesterday, actually. It looks like this only had 2 layers in the cake. Okay, you'll notice this 9D4 and 1AE. These are the layers of the cake that we have. Now this just pulled it. Okay, so now if I go to Docker images, we scroll up here, we should see Nginx Alpine right there. And okay, well, I lied. It's always been in the 16 to 18 range. It's a little bigger now, 21.2 meg, still teeny in our world. Now that's the recipe that I can now use to run Nginx on my server, and it's that small. So how do I run this? Well, let's review here. We've done Docker images. That lists all the images. Docker PS, that lists all the running processes, the running containers that we have. Docker pull, well, that pulls an image. And now we're going to run Docker run. Now, the way Docker works is when the container starts up, especially a web server type container, we need to define ports. Now, Nginx inside of the container, so think of a shipping container, and if you open up that metal box that's on the ship, you see that port 80 is what's running inside of that. But what do we want to use to call into that container? Well, we can do this. We can do -p. I'm going to give it a port externally. I'm going to say 8080. Now, I just made that up. I could have done 8000, 80, 5000, whatever you want, but I'm going to do 8080. And then Nginx by default runs on port 80. So I think of this as walking up to the box, and imagine there's a telephone on the wall of the metal container. When I pick that up, that's port 8080, sorry. That calls across the wall into someone inside of the container, which would be Nginx, and they answer on 80. So externally, we use 8080, internally, we use 80. And then we put the image, okay, which is Nginx Alpine. Now, if I run it this way, what's going to happen is it's going to lock up the console because it's going to run this container in kind of a logging mode. It's not detached, in other words. I'd have to stop this. So let me run it. And notice it kind of just locks up there. You don't really get your console back. Now you can hit Control-C to get out, but let's go ahead now and run off to the browser here. And we're going to run localhost 8080. And let's see if we can actually get to this. All right, so we'll let this load and we'll go to localhost 8080. And there we go. We now have Nginx. Let me refresh just in case it was cached. But that's how easy it is to get Nginx up and running. Now, not very useful because I doubt this is the page that you'd all want to show, but still pretty cool that we can do that. And notice it's working. We're getting logs. Every time I hit that, the container is now writing to the output here. And it looks like I actually hit Google, the gecko here, Chrome. Okay, so let's go on back to here actually. I'm going to do Control-C. And now let's go on in. Let's do Docker PS-A. Now notice Nginx Alpine. It looks like status is up for 59 seconds. Externally, it's going to be port 8080. This is going to allow us to hit localhost. And then it forwards, that's what the arrow is, to port 80. And then they gave us a kind of unique name for us. Since I didn't name the container, they called it Zealous Hoover. They come up with some pretty interesting names, actually. Now, this is the container ID. Every image gets an ID, and every container gets an ID. So what if I want to stop this container? Well, we can run Docker run to run it, Docker stop to stop it. And then I'm going to put this FF8, and I don't even have to type the whole thing. I just have to type enough to be unique to go ahead and stop this running container. So let's go ahead and do that. There we go. Now let me clear this and we'll run Docker PS-A. Now notice it says it's exited. And if we go back to the browser just to prove, nothing's up my sleeves here, let's refresh. And it's going to error here. Notice it's just kind of hanging because there we go. Site can't be reached, and we would expect that. All right, now do I still have the container there? Yes. So Docker stop can stop it. Docker RM stands for Docker remove, and that can remove it. So I'm going to now remove that container, and we should be good to go. Let's run Docker PS-A. It's as if it never existed. In fact, if we go to Docker images, if I wanted to remove this right here, notice the ID, 4D3. Well, I could do Docker remove image. It'd be 4D3. Now I'm going to use it, so I'm not going to hit enter here. And now it would be as if it never existed on my machine. That's like how you uninstall, if you will, the container. It's once you get the hang of it, it's like, oh my gosh, really? So like all that junk I'm used to having to deal with when I run through an install program, like I don't have to deal with that anymore? No. You just pull down the image and run it as a container, and then when you're done, you just delete the image, and it's as if nothing happened, actually. It's kind of crazy. All right, so that kind of gets us started here. Now let's move along and let's talk more about, so what else can we do here? Because that was nice, but I doubt you want to see the Nginx homepage. So first off, let's really quickly talk about some of the benefits to us as developers or to DevOps. First off, you can get developers up and running on a really complex system in literally a matter of probably less than an hour, easily, actually. So if you had API servers and a front-end server and even a database could be containerized, although that's optional, and all these things we've been talking about, well, I can get you up to speed literally in a matter of minutes in some cases. Depends on your network speed, of course, because you have to pull these images down. What about app conflicts? Well, I can have different versions of an app running on the same VM, but as containers. It's not like virtual machines go away. We still have to run Docker somewhere, of course, but now I could have V1, V2, V3 of the app with its own unique version of the framework and all that, and that wouldn't even be a problem. Whereas if you've ever had that problem where it's like, no, don't touch that server, because if we install a new version of the framework, it's going to mess the older apps up. Well, we don't have that problem with this. Environment consistency is huge here. I won't have time to share some battle stories much here, but let's just sum it up by saying I have not had an environment problem in over 5 years. No joke. I'm not making that up, and that includes some of the companies I work with as well. It's very consistent because this recipe, this image, well, you use it across all the environments, therefore you get consistency, and it always runs the same. It's pretty amazing. And of course, that leads to faster software. So when it comes to onboarding, that means that whether you're a designer or a developer or whatever it may be, I can get your servers, your databases, your caching, all that stuff up and running in just a couple commands, which I'm going to show you at the end today. App conflicts kind of go away because app 1, app 2, app 3, as you see here, for version 1 of some framework, well, they're all in their own containers with their own version of the software. They're all like in their own little silo, if you will. And then when V2 comes out, we can run those containers as well on the same machine even, because they'd just be different containers. And then environment consistency, of course, is extremely key for all of us because we've all hit this where, you know, it works on my machine. Well, with Docker, I always like to say it works on my machine, and guess what? It's going to work on your machine. How cool is that? Pretty neat, actually. And then, of course, that leads to shipping software faster between our environments, because now we're not just shipping code. We're actually shipping or creating these images, which we're going to look at next, and then we just run the containers in the different environments. So think of it as I'm going to give you my recipe for this really good apple pie, and you now just can recreate that at your house, at your mom's house, at anyone's house, because the recipe is consistent. And that's how Docker images will work. So the way this will work for us is, well, it's nice to have these pre-built images like Nginx that I just ran. We're of course we're going to want to put our custom code in there. I mean, they would be useless, of course, if all I could do is simply pull down a recipe that has everything hard-coded. So what we do is we create a Docker file. Now, a Docker file is a text file, as you're going to see in a moment, and we can use that to build an image. And so there's a Docker build command that will take that Docker file, and it's almost like compiling code, if you will, takes the text and it generates the Docker image. Now, here's an example of kind of pseudocode of what this could look like. So first off, in a Docker file, you'll have these instructions, they're called. One of those is from this image as my base, add a label for the author, set the working directory in this container to this location, copy my local code into, so the first dot is wherever this Docker file is, wherever I'm running this from, copy that code into this working directory. So I could have put var www app right there on the second one, but I've already typed that, so I can just alias it. So local to container, and then expose port 5000 inside of this container. All right, now to make this a little more specific, let's kind of move along here. And for instance, I could make a Node.js image. I could say from Node Alpine as the base of my cake. So I want all the Node functionality, because I don't want to write that. Let's add a label, set a working directory, copy my project code into that working directory in the image, expose port 5000, and then when this container runs, I would like the entry point, which is kind of your main entry point, if you will, to be a command, which is the node followed by the name of the server file that I want to start up. Now, likewise, if we wanted to do this with Java, ASP.NET Core, and on and on and on, we could. Now, once you have these text files, you have to build them. And that's through this docker build command that we just talked about. Now, what you do is you have to name the image. You have to tag it, it's called. So this -t is shortcut for --tag. This will typically be your repository username. So think of it as almost like a group name. This is the name of the image, the version or tag name. And then where is the Docker file? Well, the dot right there, that's our build context. In other words, we're assuming that Docker file, the text file, is in the same folder wherever I'm running this build command. Now, once we've built that text file into an image, that'll now show on your machine. And I'm going to do this in just a moment. And then we can run it like you saw earlier. Now, in this case, I'm setting the name of the container. Notice, see the -- name? I'm also running it in what's called detached. Remember earlier that when I ran Nginx, it kind of locked up my console and I saw the logs? Well, if you don't want that, if you just want to run it in the background and run it in detached mode, you say -d. Here's my external, internal ports. So I'm going to call this on localhost 5000. That's going to forward to port 5000. And then there's my image name and my version that we would have just built. Now, let's take a look at that before we wrap up with a quick look at Docker Compose. So I have a really simple HTML file here. Hello from Nginx. And let's say that I would like to create my own Nginx image, but I want to copy this file into that image because, of course, I don't want to use theirs for my homepage. Wouldn't be prudent. So let's go to this Docker file and build this from scratch. So I can do these commands like from Nginx Alpine. Now, normally you're going to put the version again. So I think it was 1.17.4, something like that, dash. I'm going to go ahead and just say from the latest, but be careful with latest. I can give it a label. You always want to know who to blame. So we'll say blame me if it doesn't work. And then I'm going to copy the index.html file into a destination folder that'll be part of the recipe, part of the image. Now, where do I want to copy this? Well, you have to know Nginx. And if we go to Nginx, if I scroll down here, you'll notice they kind of give a little demo of running it. And they give this little path, which I'm just going to copy. This is by default where Nginx looks for static files in the web server. So if you come from an IIS background, you might have your www root for ASP.NET Core, your inet pub, those type of things. Well, they call it this. So let's paste this in. And for this simple one, I'm pretty much done. So let me go ahead and save that. So we said from Nginx as my base, Nginx Alpine, add who to blame. You can put different labels in here, such as the date it was created, the author, and other things. I'm going to copy locally from index.html, which is just this file right here, into this folder that ultimately will be created in the image through Nginx. And now we're ready to go. So now I'd have to build this. And one way I could do that is docker build -t, and then just give it a name like my Nginx, and then where's the Docker file relative to this console? Well, I'm in the website folder, so the Docker file's right there. So I could just put dot. Now, if we go ahead and do this docker build -t, and I kept it really simple. In this case, normally I would put my, let me move that over. I would put my account here. And this is my either Docker Hub or my Azure, or my AWS account, whatever. But locally, I'm just going to say, let's keep it simple. And let's just put this guy right here. All right, so if I hit enter here, that just created a custom image. And notice it added some layers. Step 1 was the from, there's the layer ID. Step 2 was the label, there's the layer ID, right there. Step 3 was the copy, there's the layer ID. So this has 3 layers in it. Now, if I clear this and do Docker images, we now should have a my Nginx in here somewhere. And there it is. There it is. I didn't give it a version, okay, which you normally want to, but there's the image ID created 20 seconds ago, and it's about 21.2 meg. Now, how do I run this one? The same as before. So I'm going to do Docker run like we did earlier, but this time I'm going to run it in detached mode. I'm going to run it on port 8080 again, forward that to 80, but I'm not going to put Nginx Alpine because that's their image. I want to run my image, my Nginx. We'll hit enter. That gave me back the container ID, and then it let go of my console. That's detached. Now, if we come on in, we should be able to go to localhost 8080, and there we go. There's my hello from Nginx, and now I've customized a image. I can now push this image if I wanted up to Docker Hub, and you could all pull it down and run this image in a matter of seconds. It'd be that quick. Now, I'm not going to push that one because that's kind of a junk image. Now, let's go to Docker PS-A again. There we go. It's been up for 30 seconds. There's the image name. There's the ID. Let's stop it. A09. All right, let's remove it. A09. And now let's go back to Docker images. And where is he at? There we go. All right, so BBB2. BBB2. So if I want to remove the image, I'd say remove image BBB2. And there we go. It's as if that image never existed. Now, while you can do the commands, as a heads up, if you're using VS Code, you can install the Docker extension. That provides some great functionality, such as I can right click on the Docker file and say build, and we're done. This would actually build that image. I can name it. In this case, it called it website, but let's say I wanted my Nginx and maybe a version of 1.0. Hit enter, and now it will generate the code down here, the Docker build command, to actually create that image, and it just did. Pretty cool. Now, there's a lot more that we can go into. I'm going to run one more quick demo, talk about Docker Compose, and we're going to wrap up and take questions. But this is the basics to help get you started. You create a Docker file, you build it, that creates an image, you then run the container. Now, normally that image is, in this case, it's just local. So again, you'd have to push it up to what's called a Docker registry, such as Docker Hub, or maybe at your company, you have a registry and you could push that image up to that registry. And now anyone across all your environments would be able to pull that image down and run that container. It's actually pretty amazing. So now it's gone, the container's gone, the image is gone. If I refresh, it'll just kind of spin, and we should get an error here because the server's no longer running. Pretty cool. All right, so that's kind of the basics of how we can get started, which is really the goal of this webinar today. But let's wrap up with just a little bit more, and then we'll take questions here. So the last thing I want to mention is something called Docker Compose. Building your own images is fine, but what happens when you have that scenario I described earlier with Nginx and APIs and Redis and maybe possibly a database and all these types of things? Well, it'd be a little more painful, first off, to build all those manually, but it'd be even more painful to start all these containers manually with the Docker run command. So what if there was a way with just a really simple command to not only build, but also run multiple containers locally on your machine? Now, Docker Compose, just as a heads up, could be used in production. It's not designed for that, but it could be. It could just be used to start up containers, but if one of those containers goes down, Docker Compose doesn't monitor it and make sure it comes back up. That's where we get into things like Kubernetes or Service Fabric or those type of things. Okay, but Docker Compose can, at least locally, or even possibly on a staging type server, help us orchestrate multiple what we call services, really containers. Think of Docker Compose as the container orchestra person, the conductor, that then says, all right, flute section, you need to play. Now timpani, you need to play. Now clarinets, you need to play, and violins, and on and on and on. That's really what Docker Compose does. It's like the conductor of a little mini orchestra running on your machine. Now, what Docker Compose does is it uses something called a YAML file. Now, we won't have time today to go into the specifics, but this YAML file can be used to build and run your images and containers. Makes it very, very easy to do a build, for example. And I'm going to show you an example of this in just a moment. So Docker Compose is actually a command that you're going to see to build and run. Now, here's what it looks like in a nutshell. This is a YAML file, and you're going to have a version, and they're going to define one or more services. This is kind of like who are the orchestra members that are going to be playing. So in this case, I have some ASP.NET Core app, and I have a Docker file. Now notice the context here for building means this must be in the same folder as this. That's what the dot means there. It's going to be in a network. Networks allow us to communicate between containers. I might have a Postgres database. Now I kind of keep emphasizing because a lot of DBAs haven't, at least that I work with, haven't bought in to containerizing databases yet. Some have that I work with, but a lot haven't. You do not have to containerize anything, of course. And your container for like your web app could still talk to your regular database server as long as it has the proper, network permissions and things. But in this case, I'm going to containerize two things we're saying. ASP.NET Core and Postgres. And then they're going to have this network, which I just made up a name called App Network, and this is a bridge network. Now, what a bridge network means is think of literally a bridge being built between two sides of a lake or a stream, river. I have ASP.NET Core on one side. I need a bridge so that we can talk to Postgres. Because they're both in the same app network here, we can do that. We can talk. Now, what we can do then is we can take that YAML file and run Docker Compose build to create the images. We can then run Docker Compose up to start up the containers from those images, and then you just live long and prosper. Life is good after that. Everything works, we hope. All right, so let me show you a quick demo of this to wrap up here, and then we'll take some questions I see that we have. So let me run on back. I actually have a bunch of links I'm going to give you at the end here. One is for an Angular ASP.NET Core application. And this particular application is pretty standard. It's actually ASP.NET Core 3. I just updated it, and Angular 8 running in a container. And you'll notice I have this Docker Compose file here. Well, here we go. Now in this case, because I'm just running ASP.NET Core and what's called the Kestrel server, I can also run Angular in there if I wanted, but I could also run Angular in something like Nginx, HA Proxy, IIS, Apache, whatever you want. But in this case, it's pretty simple. Now, a little more robust example is also going to be available for you. And this is one that has multiple services. Now, I won't have time to go into all the details. There's a little bit of setup you kind of do here, but what this one allows us to do is run Nginx. That's going to run the front end part of the app, Node.js, MongoDB, Redis, and they're all going to run in this network I called Code with Dan Network. All right, and then there's some other stuff I could run as well. Now, yeah, there's a lot of YAML here you'll see, and if you're not used to YAML, it can kind of cause you to lose more hair than you want, but once you get the hang of it, it's not bad at all. I actually really, really like it. So what's cool about YAML, though, is I can do this now. If I go into the terminal, and if you want to run this sample later, there's a couple things you run here. So I'm going to first set up my environment. I'm going to set up a Docker account. I'm going to use, in this case, I just made up a name, Code with Dan. And then if you're on Windows, I show you the equivalents for PowerShell on Windows. All right, and now I would do Docker Compose build. Now what that would do by default is look for a Docker Compose YAML file, okay, the one that I just showed you. Now I've already done the build, and because that takes a little bit of time. So I'm not going to do that. But if I want to now run all those services, there was what, 4 or 5 services, I believe, I could say Docker compose up. Now this is the magic I mentioned at the very beginning, where a big benefit to developers is you can bring this up very, very quickly. Okay, so I'm going to do Docker compose up, and now I can get an entire environment running locally on my machine that are using the same images I might actually use in production, but yet I'm able to run all this on my machine. Now I didn't run it with the -d, so notice it showed me the log output, mainly because I wanted to show you that, but we have Mongo running, Redis running, Node running, Nginx, and assuming everything started up, we should be able to now go to localhost. Nginx is running on port 80, and there we go. Now this is just a fake website here that I kind of made up. In fact, when you click on things, it'll say, oops, that doesn't work because it's just a demo. But this is actually using all those technologies and pulling data from the database and caching it and doing all of that. Now, once I'm done with this, in this case, because I didn't detach it, I can do Control-C. Now we'll give it a second to kind of bring these down. And then once this is done, I can do Docker compose down. So you have Docker compose build, that builds your images. Docker compose up, that brings things up. And then Docker compose down will then kill the containers if you're done. We're going to say I'm done. Now the database always takes the longest. There we go. We'll say Docker compose down. Give this a second. Now it's done. And let me do Docker ps-a. Voila, nothing there. It's as if the containers never existed. Pretty cool. So let me wrap up, and then we'll take questions here by giving you, I'm going to have one link that you can get to all this, but there are a bunch of projects I have up on GitHub that you can check out if you're interested. I just ran well, actually, I need to add that apparently. Okay, I'm missing one on here. I'm going to have to add. No, it's right there. Sorry, there it is. Code with Dan Docker Services. That's the one I just ran. That has the Docker files. It has Docker Compose. It has all the stuff you would need to learn if you want to get good at Docker. I have a React demo, an Angular demo, and there's all kinds of stuff you can run. Now, there's a bunch of Pluralsight courses out there on Docker, obviously. I have a bunch as well. So the one I'd recommend is Docker for Web Developers. That's mine. I have a brand new one on Kubernetes. That'd be the next one after you learn Docker, though. And then these also talk about Docker if you're interested. But here's the one link you need to get to all this right here. codewithdan.me/Docker for devs. It's not just devs, but that's the link I already had, shortcut link, so I just used it. But that'll get you to the slide deck, which will then get you to all those GitHub repos and the links to the Pluralsight courses. Now, with that, I see we have a few questions here. So is Docker relevant to desktop apps or just servers and services? Let me drill into this. What if I wanted to quickly install a different version of the same desktop app? So great question, Dave. Yeah, most people are going to tell you that Docker is mainly for servers. That's actually not necessarily the case, though. Now, I personally am not using containers for any of the desktop stuff, but yes, it is possible to do that. So no, it's not just relevant to services or web apps, although, yeah, that's 99% of what you see out there. That is what people will say. I'd have to dig it up, but there's a bunch of posts out there on how you can also use containers for even desktop apps, which I think is going to change things. That might be the next phase, you could say, of some of this, because we know how painful installing and uninstalling desktop apps across like thousands of machines can be. So, you know, who knows? Maybe someday it won't be like that. Well, we can only hope. So great question. Randall, how are security updates managed with Docker images? Yeah, so that's actually a really pertinent question, Randall, because you all know how this works in real life, right? Like you have a server out there, Docker or not Docker, doesn't matter. And a security breach is found. Now you got to patch it. Well, normally that means without Docker, you'd have to go to the server itself and patch it. And we all know how that can go. Like what happens when the patch didn't work right and it blew something up? Well, the nice thing about containers is, first off, images are immutable. you don't go and patch an existing image. You make a new image. So the answer there would be you would go in, pull the latest image that has the, let's just say it was a security patch, and then you would now deploy that for your application. So think of it as you're never going backwards and fixing things. You're always going forwards. Now, what's nice about that is you actually could keep the older version of the app up and running while you push out the new patched app. And then once that's good, you could switch the network traffic. There's all kinds of fun stuff you could do with like Kubernetes on that. So yeah, that's how you're gonna do it though. You don't ever modify an existing image or container. You could modify a container. That's not the recommended approach though. So great question. Let's see here, Venki. Yeah, thank you. We're designing lots of APIs, each having its own data store. Okay, so it sounds like microservices maybe. These APIs talk to each other, use endpoints. Should each API have its own Docker file, and how will they be linked? Excellent question. Yeah, Venki, it sounds like you're getting into microservices then. And yes, each one of those would have its own Docker file and probably multiple Docker files, because if they're also going to have their own database, you never want to mix what we call concerns in a container. You can, but you shouldn't. So in other words, you shouldn't put a database in with like Node.js or Java or ASP.NET Core. You always want to make separate containers. The reason there is now I can independently scale those, and we didn't have time to get into scaling, but that's another benefit of containers, is that you can scale them. And it also means that if one of them crashes, it won't affect the other one. And that's also a good thing. So yeah, each one would have its own Docker file, Venki, your API and your database if you had that. If you have other things related, such as, I don't know, maybe a logging server that service uses, that'd be a third container, third Docker file. But yeah, that's exactly what you would do. Can a Windows service be containerized? Yeah, actually, Chad, that is a capability now that you can actually do these days. On Linux, you know, they don't call them Windows services, but they've had services for forever. And you can totally do that. And if you're using Windows containers, you can totally do that on Windows 2016 or 2019. So yeah, you can actually containerize services. Okay, Jonathan, could an image be used to provide a new developer their development environment? It provides them with, yeah, technically you could, Jonathan, do that. I personally, you know, I'm using like VS Code and all that so much, or Visual Studio even if I'm doing .NET, that I normally just have those installed. But if you're bringing on like a lot of new hires and wanted to containerize that stuff, it is possible to do that. Now, that's a little beyond the scope of what we covered. There's more to that story. But yes, in a nutshell, it is possible to do that. That kind of relates to somewhat Dave's question on desktop apps, actually. And then, is there a performance hit using a container? The container itself, no. Now, what you do in the container, possibly. We didn't have time to get into, in fact, there's a little bonus content at the end if you're interested on something called volumes. Volumes are where a container can actually talk to the local operating system file system. And so there could be some scenarios where that could impact performance possibly, but it really depends what you do. Let's just sum it up this way. A lot of the most popular companies out there, Netflix would be a prime example, everything's in containers. So they run really, really well. Yeah, so Rakesh, I hear Docker is used for microservices, definitely. In fact, I think microservices without containers are a nightmare because now you'd have to maintain all these VMs. It's possible, but I just think it's way more involved. So yeah, and there is actually, it's a pretty simple example, Rakesh, but if I go back to here, whoops, let me see if I put this one in. Okay, no, I didn't. There's this Angular Docker microservices. That would give you some. I also have one with ASP.NET Core though. It's up on my GitHub repo. And it's kind of a simple, has 2 microservices with their own databases. So yeah, absolutely, this is a good candidate for that. Okay, David, if you delete or stop a container, you're supposed to type far enough to be unique. What if you type in a start and it matches 2? Excellent question. Yeah, so remember when I was, let me go back to here just really quick, and I was doing stuff like this, Docker remove, you know, something. And I said it just has to be unique. If it's not, you'll get an error, and you will be required to actually be more unique. Now, you can also use the name of the container. Either you can name it, or as you saw, they will give it a name. I never do. I always use the IDs because it's easier to type. But yeah, it will ensure that they're unique. So I think you're asking because you're probably wondering if they'll accidentally delete something you shouldn't or stop something you shouldn't. No, that won't be a problem. All right, Hater, how does Docker work with the context of CI/CD? Oh yeah, excellent question. So Docker Compose, Hater, is a great tool for CI/CD, and here's why. Normally with CI/CD, let's say you're using Jenkins or Azure DevOps or whatever it may be, you know, you a lot of times have a physical VM where you have to install the software to do the builds and all that. Well, with Docker, you don't. You could actually fire up a Docker Compose command as part of your pipeline. That could bring up the containers. The containers are then, through something called volumes, can either pull in the code from like a repo or get to them on a hard drive somewhere if that's how it worked. And you could do the build in the container. And then when it's done, you just delete it. Done. And now anytime you want to update that build process and maybe the version of like the framework you're building, then you no longer have to ever touch the VM. I never ever install stuff on VMs anymore except for Docker. That's it. Everything else I do through images and containers. Because now when I'm done with something or I need to upgrade something, I just swap out for a new image and boom, I have a new container. So there's a lot of potential there, Hater. That's a great question. See, I do demos for SQL Server and lost my environment multiple times. Would creating a container all prep with server configs for the demos? Yeah, absolutely. Let's see, Elena, hopefully I'm saying that right, Elena. Absolutely, yeah. You could, for instance, if you're using SQL Server on Linux, and you could do this on Windows as well, by the way, but SQL Server on Linux in particular, you just pull down that image and tweak it. You know, well, you can build your own image first off, and then every time you do a demo, you just start up that container. If something goes wrong, like you, I don't know, messed up the data or the security, you just blow away the container and bring up a new one. And that literally take, you know, probably less than 60 seconds, something like that. That's great. I do that all the time for demos because if something goes haywire, I can just be like, oh, bear with me, and I'll run over. I'll typically, in that case, run a Docker Compose down. I'll kill stuff, and then I'll bring it back up with the up command. That's a great example. How about performance? So Gustavo, can Docker serve several clients connect at the same time? Absolutely. It's no different than a normal web app. So if you had, for instance, IIS, Internet Information Services, in a container, the same power and flexibility you would have with IIS on a virtual machine would be the same in the container, or Nginx, or whatever it may be. And again, I kind of point you to, when you're hitting Microsoft these days, you're hitting containers for the most part. When you're hitting Netflix or Amazon, you're hitting containers. Of course, it depends, but for the most part. A lot of the massively scaled companies out there have all moved to containers, because if a container crashes, it's not like a VM crashing where you're like, oh my gosh, the VM went down. What do? We got to bring up a whole new one, and then that might take who knows how long to reboot it. With containers, and especially with something like Kubernetes, we can just make it where if that container goes down with Kubernetes or Service Fabric, it would just auto restart the container. And you can even do zero downtime deployments where you deploy a new version of the app. Instead of killing off the old one and having downtime, you can keep both up at the same time. And then once the new one is ready, you just switch the network traffic. So yeah, performance is great, actually. Let's see, Mike, so you could potentially run IIS. Absolutely. Yeah, now I will say, Mike, the IIS containers, the images, I should say, are big. The Linux ones, you're normally looking at maybe a few hundred megabytes, depending. The IIS one's pretty big, so just keep that in mind. But here's the cool thing. Once you pull an image, if somebody publishes a new version of that image. Let's say you published version 1 and then I published version 2, but only 2 layers of that image cake got changed. Then when I go or you go to pull down the V2, you won't pull the whole 1 point whatever gigabytes. You'll only pull the deltas, the changes. That's a really nice thing about how the layered file system works there. So yeah, but you can absolutely do it. And so yeah, if you use Visual Studio, they'll do this for you, Mike. Go in, and when you create a new ASP.NET Core or even an older ASP.NET MVC 5 app, check that Docker checkbox in Visual Studio. That will generate all the code needed to run IIS if you're doing like web forms or MVC 5. And it generates everything for you. And when you run and debug, you're actually running that inside of a container. So yeah, it's pretty impressive what you can do. They just keep in mind though, it's kind of big. But again, it caches them, so it's like a one-time hit, but any future change is not too bad. Ray, how do you add SSL? Yeah, so to add SSL, let me go back to here. Basically, you would do this copy command to copy the necessary or appropriate cert files into the appropriate server location. I don't know if I think I do have it actually. Let me go look real quick at my Nginx production one. I think I do that. Yeah, right here. See these copy commands here? Well, that's in essence what you do. So depending on your server, because every server has different locations it looks for the certs, I'd pop in my keys that I need, my cert files, and that is now part of the image. Now, of course, there's other ways to work with certificates, but this is kind of the normal way you'll see right here. All right, Andy, thank you. I assume it's possible to use Docker to deploy just the differences when we want to deploy a new version. Yeah, that's exactly what I was talking about with Mike. Yeah, when you deploy a new version of an image, most of the layers probably didn't change. Only a few of them probably changed. And so in that case, it's just going to pull the differences. And that's what's so awesome. If I came in and I pulled, you know, the Nginx Alpine, for instance, well, I just pulled it, you saw earlier, so we probably won't see much, but let's see what happens here real fast. Okay, see how it was instant? Because there was no differences. So it didn't have to re-pull it. But if there were differences, I would only get those changed layers. So you do have to deploy the entire image though, Andy, but it only deploys the differences. So yeah, it's really efficient. Okay, and let me know when we got to cut things off on the recording. Let me know. I'll keep going as much as we can. Phil, when were you looking at the Dockerfile and VS Code? You seem to generate a Docker build command. How did I do that? Yeah. So I was back here, and this works on Windows or Mac or Linux for VS Code. So if you're on VS Code and you go to the extensions, I have an extension installed called Docker, which is actually from Microsoft. It's just an awesome extension. I highly, highly recommend it. And once you install that extension, it has this little whale icon. And now I can actually see any running containers. I don't have any right now, but let's see. Let's try to run. Watch this real quick. I'll run Nginx Alpine. All right, now give it a sec. There we go. See how that now shows it? Now I can right click. I can view the logs right here. Now there are no logs right now because I haven't hit it yet. I can stop it. So give it a sec. There we go. I can remove it. And all that was done with no command line. Pretty cool. And then likewise, the build that you asked about, that was a matter of the Docker extension, and I just right click and I say build image. And then it pops up, all right, what do you want to call it? What do you want to version it as? And let's say we wanted, 2.0, I would just hit enter. It's an awesome extension. I rarely type the commands when I'm in development mode because the extension is so much faster. So yeah, check that out. Docker, just go to the extensions on VS Code. Pretty awesome. Let's see, how do we obtain HA with Docker containers? Venkat, HA, do you mean HA proxy? What do you mean by HA? Let me know, and I'll come back to you. Chad, what's the difference between Control C to stop? Yeah, so Control C, it depends on the container, Chad. Sometimes it will actually stop the container. Otherwise, other times it doesn't. It depends, I found. So normally you're not doing Control C because when you start up either Docker Compose, like if I do up, you can do a -D command, and that's detached. And then you don't have to do Control C. The difference though is Docker Compose down not only stops the containers, but it also deletes the containers, removes the containers. Whereas Control C doesn't remove them, it just may stop them. So that's kind of the big difference there. Venkat, if servers hosting Docker containers and DB reside in different subnet, how do we open port from a container? You don't from the container. When you run a container, you can say the port, but if you have a network set up, you're going to have to go into your network policies and expose that external port. So like on Azure as an example, I have to go in and go into their policies. And if I have MongoDB as an example, normally it's shut off. I don't let people, including myself, get to 27017, the port. I have to go in and set up a rule to allow that. So with Docker, all you do is you expose the port, the external port, like 8080 that I did. But then in your network policies, you'll have to then make it so people from the outside world can get to it. Docker doesn't do that because that's a networking thing. Is there a limit how we can create Docker containers max? Yeah, the limit would be your memory and possibly hard drive space and things like that. No, you can run thousands and thousands of containers. I don't have time to bring it up, but if I brought up my Kubernetes demos, I could show you, we could scale out a container or containers to literally until my machine just cried for mercy. So yeah, there's not really a limit. The limit again, it would be your memory and stuff. So you'd want to be careful to, in that case, you'd have to scale out, horizontally scale your VMs that run Docker. But that's where you're going to want to use Service Fabric or Kubernetes. Thanks, Jim. Appreciate it. That was an easy one. Let's see, Ravi. Oh, okay. How's you got a multi one here? How's Docker different than Cloud Foundry and IBM Blue Mix? You know, Cloud Foundry will do a lot of think of it as a higher level abstraction of this that will help you with this. Now, I have not used IBM Blue Mix, so I can't really comment. But I guess you could say, Ravi, the difference is with Cloud Foundry, you can do a lot of what I showed, but not have to be so down in the weeds with the commands and things. You can set it all up in there and just get everything up and going in your environment much easier with templates and things. Oh, great question here, Jamie. What's the best Docker training resource? Gosh, I'm not biased at all, but no, go check. Polton has some awesome courses up on Pluralsight, and he is just awesome to listen to. He's just really funny to listen to. I like him. He's super good. The Docker for web developers here, if you want to get into that, it has all kinds of great info. That's mine. And then there's others. But those are the two main ones that I think most people, at least on Pluralsight, go see. One of these two. Is training online docs? Oh yeah, docs. Let's look at that just really fast here. So all the stuff I use a lot, I have API docs you'll see right here. And like for Docker, I have everything bookmarked, but they have really good docs overall. You can go to docker.com, and then from here, you can get to like Docker Desktop, image, all that fun stuff, but then they also have resources like the docs. Now, you kind of have to know your way around the docs. I won't lie, it's like anything. It's a little bit of a learning curve. Now, for me, like for Docker files, I can just link right to here, and that takes me to, let me make this a little bit bigger. That takes me to all the commands like the from, the run, the command, the copy that I mentioned a few of these earlier. I'd love to say I have everything memorized, but there's just too much. But I'm pretty good at finding things fast. So I would recommend get good at the Docker docs themselves first, and then also check out, as you're going through, for instance, Docker for web developers, I always recommend this in my training classes that are in person as well. Take the time to go look up that command, because there's always more details, of course. So lots of good stuff in here. Is it possible to use DOM, DCOM, legacy systems? Yeah, technically it is. I have not done that, and I'm probably not going to say your name right. Kier? I'm probably saying that wrong. Sorry, but or Kier. That's a great question, and I could totally see that for legacy apps. I have not done it, but because you can run Docker on Windows, and because you can run, COM still, even on the newer Windows, that should be possible. Now, that is one I personally have not done, though, at all. I'm happy to report I haven't had to touch COM in many years, but it still works. Okay, Jamie, what would you say to an organization that's primarily Windows-based and has no choice to remain on Windows if they're looking to containerize? Yeah, definitely, Jamie, take a look at the Windows container functionality. Microsoft's put a ton of work. Now, you do have to be on Windows Server 2016 or higher. So if you're still on an older Windows Server, you would have to move forward on that. But definitely look at, you can containerize, as somebody asked earlier, things like IIS even. And a lot of companies are doing that now to get their, for instance, web forms apps off of being tied to a specific VM or specific hardware server. And instead, they're making it so that you can just containerize it. And that's why in like Visual Studio, again, I don't have, unfortunately, time to show everything, but in Visual Studio here, I have 2019 and 2017 here, but when you create a new project, you're going to get that option now to check a box that says enable Docker support, and then you have an option to choose Linux or Windows. So I'll just show you really fast here. Well, as fast as it will go. There we go. So let's say we did a, let's do ASP. This is kind of locking up on me. There we go. ASP.NET, and let's say it's not core. What happened there? Shoot, I must have accidentally closed it. Well, anyway, when you pick it, let me just go in this way real fast. I'm gonna do continue without code. All right, I'll let this launch, and when you pick your even web forms, all the way back to web forms, I'm trying to remember, I think you can go back as far as 3.5 or 4. I can't remember which, but you can go pretty far back. It's gonna make me sign in. All right, I haven't used this image in a while that I'm on. But anyway, when you create that project, just check that Docker checkbox and then select Windows as the containers, and you would be off and running. Pretty cool. All right, a couple more here, and then we'll wrap up. Is this code you're showing in VS Code available? Yes. All the code, like this one here that I was showing that had the more robust example that ran the website, that is all in the slides. So all you need is this one link right here. And once you get that, that'll get you to this info, which is all up on GitHub. This is the more robust project right here. It's called Code with Dan Docker Services. This is actually what I build out in the Docker for Web Developers Pluralsight course. So I kind of show how to build that from sort of scratch. And that'll get you up to these Pluralsight courses as well. So yep, let me go back. So you just need that one link right there. What app are you using to code? So I use VS Code pretty extensively, Raphael. But if I'm in a pure .NET app, I still use Visual Studio. But if I'm doing, Node, ASP.NET Core, because I run on Mac and Windows, so I like VS Code because it runs everywhere, and it has that great extension I told you about, the Docker extension. So, all right. Well, I think that's it. Great questions. Thanks everyone for taking the time to spend an hour or so with me. And hopefully who knows, maybe we'll do some more of these a little bit later. If you have any suggestions, let Pluralsight know, and we'll go from there. And with that, I'll kind of wrap up here. let's see, one final thought. Well, I guess my final thought would be this. The question I get a lot would be, is it worth my time to learn Docker, even if my company's not using it? Because again, I question everything. That's just me. I question, why would I want to learn it? Where would I use it? Why would I use it? You know, because I don't want to invest time in something that's a dead end. So first off, I think this is totally worth your time. Even if you say, well, my company's not ready to move to containers, maybe you're the person that helps get them there. It has literally revolutionized how we do deployments and how many companies I work with do deployments. I was at Intel a couple months ago, actually. They're moving tons of stuff to containers. Microsoft, Amazon, Netflix, you name it, they're moving to containers. And you may say, yeah, but we just have internal apps with not as many users. Do we really need containers? Even then, I think there's huge worth in learning containers, learning how to build images, and then run these containers. Now, it is a learning curve. I'm not going to lie. You know, I've been doing this 1 year shy of when they started. So I guess I've been going a little over 5 years now with this. So now it feels normal. But when I first got started, it was challenging. So I guess my last thought to really wrap up, because now my thought's many thoughts, is it's worth the time and it's worth climbing the mountain to get to the top, because once you get to the top, it's like rolling boulders down the hill and they just fly. And it'll completely change how you look at working with software, not only building it, but also deploying it.